What's up, what's up, what's up? It's your boy, the network. And today's topic is Section 3.15, Configure and Verify Loop Prevention Mechanism. This is subsection 3.15b, Split Horizon. This is a topic in the CCNP route exam code 300-101, version 2.0. Let's take a look at the exam blueprint and see where we came from and where we're headed. All right, this is the exam blueprint. Implementing Cisco IP routing, also known as the CCNP route exam. That's the exam code 300-101. We wrapped up 3.15a, route tagging and filtering, right? Today we're going to be doing split horizon. After that, we're going to move on to route poisoning. So, split horizon, what is it? Obviously, being that it's a subsection of configure and verify loop prevention mechanisms, it is a loop prevention mechanism. So, what is a routing loop? Obviously, is when a packet goes into the network and somehow you must have hired a network engineer who doesn't know about time to live and all these loop prevention mechanisms, and causes the packet to loop in the network, and it would just loop all day, right? Luckily, there's time to live, and it would just die off. However, you're trying to avoid that altogether, and that's what these mechanisms do. So split horizon is one of those mechanisms, and the way split horizon works, before we even get into that, let's talk about, I don't know if you remember the game we used to play as little kids called telephone, right? You got one kid will whisper in one kid's ear, you'll whisper it to another kid's ear, whisper it to another kid's ear till it gets to the last kid, and then he's supposed to announce to everybody what he heard, right? And it's usually a tongue-twisting sentence just to kind of throw you off. Well, let's go to these slides real quick. Let's say you got these line of kids right here that's playing telephone. It's also known as Chinese whisper in some other countries. I didn't know that. Over here in the United States, we call it telephone. But anyways, you got this kid over here on the left-hand side holding this note card, and it's got this tongue-twisting sentence. He's going to say it to this kid next to him, and he's going to say it to him, next to him, next to him, next to her, to her, to her, and all the way till it gets to the last kid. And then she's supposed to say what she heard, right? And usually she's going to most likely she's going to mess it up. But let's say, for the sake of, routing protocols, and this is the same way a routing protocol shares networks, right? Or shares routes, rather. It shares it to the next router, to the next router, to the next router. They will be sharing routing protocols, right? Or sharing routes, right? Let's say we got these two kids right here, one in an orange shirt and one in a white shirt. Let's say they didn't really know how to play telephone, right? And once the message got to the orange kid, right, it traveled from here and it went to the orange kid, right? He said it to the kid in the white shirt, but the kid in the white shirt don't really know how to play the game. So he went ahead and turned around and whispered it back to him. And he know how to play the game, but he whispered it back to him. And then the message just keeps going back and forth between the two. This would be akin to a routing loop in the network. And then, therefore, these guys don't get the message, or in this case, the route that we trying to share. And then we would just have this loop, and it would just happen all day until one of them figure out how to really play the game. Or we hire a network engineer to fix all of this. So that's how we can think of a routing loop. Well, how does split horizon work, right? Well, split horizon will basically tell the kid in the white shirt how to play the game. That's basically what we're doing with split horizon. But let's go ahead and bring it to the real world and talk about how split horizon works. So, official definition. In computer networks, split horizon route advertisement is a method of preventing routing loops in distance vector routing protocols. We know what those are, right? RIP and EIGRP, right? Because OSPF is what? Pop quiz. It's not a distance vector routing protocol. What type of routing protocol is it? If you know the answer to that, put it in the comments below. By prohibiting a router from advertising a route back onto the interface from which it was learned. So in other words, let's pretend these two kids are routers, right? He know not to whisper it back to him because he already know the message. He's supposed to whisper that same message back to this girl right here, and she's supposed to whisper it to her, and so on and so forth. That's the way sharing routes is supposed to work, right? The concept was suggested in 1974. A little, trivia for you real quick. It's suggested in 1974 by Torsten Kegrell. I don't know if I'm pronouncing that right. And originally implemented in the ARPANET-inspired Swedish network TDAS. Y'all know what ARPANET is, right? That's basically the original inception of the internet, created by the military in the United States. So let's bring it to the routers in the network, right? Split horizon rule. Again, it basically says never advertise a route out of the interface through which you learned it. So we looking at these routers. Let's make pretend they're the kids, right? We have a route. This is an RIP network, right? We have the router 3 knows about the 10 network, right? He advertises it to router 2, right? Router 2 learns about it. So he says, okay, I know about the 10 network now. Let me go ahead and let router 1 know about it. So he lets router 1 know about it, right? Split horizon says, you learned it out of this you learned that interface, that network out of this interface. Don't advertise it back out, or else we'll have a loop. Because if it comes back out of this same interface, router 2 is like, oh wow, the 10 network. Let me tell router 1 know about it. And then that same information is going to go back, and then we'll just have a loop. Matter of fact, we're going to fire a packet trace, and I'll show you how that works. That's basically what the split horizon rule does, right? We stop loops from happening by not advertising out of the same interface we learned information from. So how do we enable or disable it? It's real simple command. In EIGRP, you do no IP, split horizon, and then EIGRP, and then the ASN of EIGRP. In RIP networks, you just do no IP, split horizon, and then you just go, but you have to go in the interface and do this, right? It says right here at the top. Let's go ahead and fire up packet tracer, and then I'm gonna show y'all, actually, we're gonna also show it to you in EIGRP in GNS3. All right, so I even got some steps here. I created a little quick lab for y'all. This right here, same thing. This is a RIP domain right here, right? We got a RIP domain, and this is why I guess because RIP is a simpler routing protocol. This is why we use it still when we're learning about networking and stuff. It's really outdated routing protocol. It's been, surpassed by OSPF, and EIGRP is now open source. So it's not, you can't just use, you don't have to just use it on Cisco routers. You can use it on any type of router that can support EIGRP. But anyways, we learning about RIP. So first thing we're gonna do, examine router 1's routing table. Before we even do that, let's examine this topology as a whole. We got PC1 in the 1001 network, right? We got a router 1 that sits in between the 1001 network and the 172.17.00 network. These are both /24 networks, and we got router 2 on this side, right? Again, this is the entire RIP domain, all of this, right? They are sharing RIP routes. So let's go ahead and examine router 1's routing table. All right, so we are on router 1 right now, right? So enable show IP routes. You'll take a look at his routing table, and as you can see, router 1 knows about, obviously he knows about the 1001 network because it's local, it's connected to him. It's directly connected to him. He also knows about the 172.17.0 network. That's also directly connected to him. Let's examine router 2's routing table. That was real simple enough, right? Let's go through this real quick. This is real simple. Enable show IP routes. And you can see he knows about his connected interfaces. He knows about the 172 network, right? He has a loopback on him, 172.1.2. Is that a loopback? No, that's not a loopback. That's a gigabit interface. He also knows about the 1001 network. So he knows about this network through RIP, right? This is an RIP route, as you can see. Let me go ahead and bring that up. So he knows about that via RIP. AD is 120. The metric is 1. He learned about it through the 172.17.1.1 network, right? Now, let's go into simulation mode to filter traffic only for RIP so we can see just the RIP traffic. Because remember, RIP messages go out every 30 seconds, right? So let's go into simulation mode. We are going to filter RIP routes, packets. So we're going to edit, show none, RIP. So now we're only going to see RIP traffic, right? Shut down the 10.01.0 network. So we're going to shut this down. Theoretically, he should know about it once it's shut down, right? Remember, he knows about the 10.01 network via RIP, right? So let's go ahead and shut him down. Shut down this network is what we're doing. So that way he knows about it. Or hopefully he know about it. Interface configure terminal interface GI00 TI 00 and then shut down, right? So we shut him down, and now look, now that we shut him down, we're queuing an RIP message to let him know about it, right? So router 1's going to let him know about it. Let's see what happens, right? Examine router 2's routing table. So before we do that, let's examine his routing table. We already did that, so we know that to get to the 10 network, we got to go to 172.17.1.1, which is that interface right there, right? Fast forward one frame. Let's do that. So we got a message coming to us, obviously. Let's see what we got. Examine router 2's routing table once again. Show IP routes. And now we got a message that says 10.0.1.0 network is possibly down. We learned this. We're going to be routing via 172.17.1.1. Well, guess what? That's the same interface we learned that from, right? Let's disable. Uh-oh. This don't sound like a good idea. Disable split horizon on router 2's GI00 interface. This sounds pretty catastrophic, right? Let's go to router 2. We are in there already. Interface, configure terminal. We're going to go into global config mode. Interface GI00. And we are going to disable split horizon. Do you remember how to do that? Pause and think about it. We back. No, we said it in the slides earlier, right? No IP split horizon. We're not doing EIGRP. It's an RIP route. So it's just no split horizon. IP split horizon. All right, so we turned off split horizon there, right? Next thing says disable split horizon on router 1's GI01 interface. Before we do that, let's see let's confirm that it's even on. Normally it's enabled by default, but let's see what happens. Let's check out the status of it first real quick. Do show IP. This is how you verify it. Interface GI00, I believe it is. Yeah. So we do that, and then obviously it is right here. Split horizon is enabled. That's how you know it's on. It's enabled by default. You're probably wondering, when do we need it off then if this is a loop prevention mechanism? We'll get to that in the next lab. So now that we know it's enabled, it says here, disable split horizon on router 1's GI01 interface. Okay, we did that. We got to do it on router 2. I guess I did it backwards. Router 1's GI, yeah, router 1's GI00. I wrote those steps down wrong is what I did. No IP split horizon. Make sure we did it right on router 1. GI01 router 1. So exit. Let me make sure. Interface GI0/1. No IP split horizon, right? So now let's see what happens. It says here, fast forward and watch the loop occur. Uh-oh. Fast forward. We got an RIP message, right? Remember, RIP comes every 30 seconds. Let's fast forward one more time. Uh-oh, that message is sent it back to him. He gave him the update. He sends him another update. You can probably guess what's happening here, right? This is what you're seeing here is a routing loop. Obviously, to fix that, we need to have split horizon turned on. This is why it's enabled by default, so you ain't got to worry about this. 9 times out of 10, you ain't going to be running into a rip network, but this is the way to fix split horizon. I'll show you one more time. Basically, we got a loop. All right, so let's go ahead and move on to GNS3, and I'm going to show y'all split horizon in an EIGRP network. Now, the reason why we would want to turn it, now with the thing with EIGRP, not even just EIGRP, non-multi-access broadcast networks, you need to have it turned off. And for that reason is because, remember, when you have multi-points with like frame relay, for example, you'll have an interface, you'll have a update coming into one interface, but split horizon usually uses sub interfaces. So technically it's not the same interface. So we do want an update to come out the other interface, right? Matter of fact, we covered that in the frame relay video. I'll leave a link in the description below so y'all can go over that just to review if you need to. But yeah, let's go ahead and experiment with split horizon in EIGRP. Now, again, when you have a non-multi-access broadcast network, that's when you need to have split horizon turned off. Actually, you would need it turned off in this case. Okay, so we have a frame relay network right here, right? We got router 1, router 2, and 3 respectively, and they each have their own loopbacks, right? Quad 1, quad 2, quad 3, right? Says here, you are not allowed to make any changes to the frame relay configurations, right? So we ain't gonna touch this guy right here. Configure EIGRP AS123 on all routers and advertise all networks. So we need to make sure they know about, we need to make sure that these all become neighbors. I should have pre-configured that too. Let's go ahead and console into router 1, enable, configure terminal, router, EIGRP 123, network, and we're gonna do quad 0. So that way we're advertising EIGRP on all networks. We're gonna do the same thing on router 2. Enable, configure, terminal, router, EIGRP 123, network, quad 0. We should have a neighbor come up pretty soon here. Let it go. So now routers 1 and 2 are neighbors, and we need to make sure router 3 becomes neighbors as well. Neighbor, configure, terminal, back router, EIGRP 123, network, quad 0. And they should become neighbors. So routers 1, 2, and 3 are neighbors. They are in the EIGRP domain. This is the 192.168.123.0 network /24. Let's take a look at router. It says here, ensure router 2 and 3 can see each other's loopback interfaces. Well, let's take a look at router 2 and see what he knows. Router 2 has an adjacency, obviously. Do show IP route. He knows about the 2 network, which is obviously an interface that is configured on him, the loopback, right? And he knows about the 1 network via EIGRP. He learned about that through EIGRP, but he don't know about the 3 network, which should be on router 3, right? So he knows about the router 1 and his loopback, but he don't know about router 3 and his loopback, right? They're EIGRP neighbors, right? But remember, this is a frame relay network, so they are not broadcasting, right? What we need to do here, let's see. It says here, ensure router 2 and 3 can see each other's loopbacks. Can router 3 see router 2's loopbacks? Probably not, right? Let's go ahead into router 2. I'm sorry, router 3. Do show IP routes. He knows about the 1 network and the 3 network, which is basically router 1 and router 3. So what we need to do, so what's going on here is we're having EIGRP. We have a neighborship here, and we have a neighborship here, but we don't have a virtual neighborship here, right? Why? Because we need to have some sort of, basically we're advertising here, but it's not coming back out because it's split horizon. Split horizon is enabled. So he's got router 1 has information coming out of this interface, but it's not coming back out because the split horizon rule is turned on. Let's go ahead and router 1 and turn it off and see if that fixes the problem. Obviously, they couldn't ping each other because they didn't have routes to each other. So let's go to router 1, go to that interface. What interface do we need to do that at? Obviously, this serial 00 interface. But we need to do it because it's EIGRP, right? So we get out of this. Let's verify that it's even on. Show IP interface serial quad 0. Do show IP interface brief. Let's exclude the unassigned. Get rid of the do. Do the do. Okay, so we needed to do it on the sub interface. My bad. So let's show IP interface serial 00.123. You can see split horizon is enabled, and that is the problem here. So what we need to do is configure terminal interface serial 00.123. Go into that sub interface and do a no IP split horizon EIGRP, right? Yeah, EIGRP Remember in RIP, you just do no IP split horizon. In EIGRP, you got to do no IP split horizon and then the AS number. In this case, it's 123. Now we essentially turned off split horizon, and as you can see, it says here split horizon changed. EIGRP is resynced itself basically. Let's take a look at router 3 and look at his routing table. Show IP routes. And now he can see the 1, the 2, and the 3 networks. All 3 networks. Let's go to router 2 and see if the same thing happened. As you can see, that's how his routing table looked like before, right? He see the 1 and the 2 network. Do show IP routes. Now you can see the 1, 2, and the 3. Can he ping the 3 network? Can router 2 ping router 3 now? Do ping the 333, right? That was the quadruple 3. So basically we have router 2 ping router 3. That loopback address. Oh, you know what? It's not. There go another mistake right there. I'm not auto summarizing. I'm auto summarizing. That could be an issue right there. So let's make sure we not auto summarizing. Let's go back to router EIGRP 123. Auto, no auto summary, no auto, and let's copy that on all the other guys. So now we are resyncing EIGRP. Router EIGRP. We need to go EIGRP 123. No auto summary. Let's do the same thing on router 3. Configure terminal. Router EIGRP 123. No auto summary. And we resynced EIGRP. Let's see if router 2 can ping router 3 this time. I'm going to ping quadruple 3 with a source IP of the loopback. And we went ahead and did that. We pinged router 3 with the source IP of loopback 0, which lets us know that they can see each other's loopback addresses. If you like this video, please comment, like, subscribe to the network.